this is reflective about the line y is equal to x, and you should say, I knew that already. We know we did that in semester 1, but again, really want to emphasize it, and that you see that symmetry. So here, this is a little trickier, but this guy is going to be your exponential decay, which we just took a quiz on today, right? Its inverse then is this log function. Let me highlight that. This is the log, and this would be log, like a log base, 1/2. It would be a base that's less than 1 greater than 0 of x. These are pretty tricky, and I'll say right now, we're not going to graph any log base less than 1 greater than 0. We will focus on our course on just bases greater than 1. We need to talk about domain here. Check it out. Again, exponential growth, the domain was always all real numbers. Unfortunately, when that switches, so the range for a log function now is all real numbers. No restrictions on the range. We can get negative values out. 0 comes out of the log function greater than. But for the domain of the log function, now is x can only be bigger than 0. And realize that that is the range of the inverse function. So when you switch x with y, you also switch domain and range. And hopefully that all made good sense to you. So how will we graph a log function? We plot points. And so again, realize that this log function, and a lot of times I switch, right? I'm going to think of this as, instead of thinking log base 2 of x, I'll think, oh, that back in its exponent form is 2 to the y is equal to x. So how do I make x, 2 raised to what power will give me 1? Oh, x has to be 0. 2 to the 0 is equal to 1. 2 to the what is equal to 2. 2 to the 1 is equal to 2. And notice we skipped 3, because seriously, I don't know. 2 to what power is equal to 3? I don't know. So I skip it. And that's really important for you to know, right? I skip to 4. Why do I skip to 4? Because 2 to the 2 is 4. So realize that these numbers for x, you can't just plug in 1, 2, and 3. You have to be selective, right? And you'll see that in a second. So here I'll plot my points. 2 is 1, and 4 is 2. And again, knowing that shape, we come up and, oh, I missed a few points there. Terrible. That's not bad. And realize again, your domain is x is greater than 0, and your range is y, for y is all real numbers. We can also translate here, right? So check this out. I can subtract 1 from the x values. You're saying, hey, that's a horizontal shift. Add 1 to all the x values. And I could add 2 after the fact, which is a vertical shift. So I'd add 2 to all functions. So first we would start without the horizontal shift. So we're just going to do log base 3. 3 raised to what power is equal to 1? 0. And you see how I'm undoing that? I'm talking like backwards. I'm thinking of 3 raised to what is equal to 1 or 3 or 9, right? These values of x end up being the answers if I undo the log function. And that makes log functions tricky. 3 raised to what power is 3? 1. 3 raised to what power is 9? 2. And now I've got my points, right? At 1, 0 here, notice the scale of 2. At 3, I'm at 1, and then that's 4, 6, 8, 10, so 9 is 2 here. But what do I have to do to these guys, right? I got to add 1 to the x values, and I need to add 2 to the y values. So they already added the 1s. They're so nice, right? 1 plus 1 is 2. 3 plus 1 is 4. 9 plus 1 is 10. And I'm going to add 2 to the y values. That's 2. That's 3. That's 4. And so I'll have my new graph here at 2, 2. At 4, 3. And you can kind of see how these points are getting shifted, right? And then at 10, 4 here. And then I've got my graph. Notice that my asymptote, and I didn't mention that earlier, I apologize. I do have a vertical asymptote here at x equal to 1. And why do I bring that up now? Because of the domain. The domain here is x is greater than, not 0 now, but 1. We shift that. And the range is all real numbers. I think that's it. I will see you tomorrow. Good job. If you follow this video, it's really going to help you tomorrow. Thank you.